There we go. Good. That's good. Calculator. Get this to load the skins. Good. There we go. All right. Start it off. There we go. Bum bum ba-doom. Let me. My screen. What's up, Ethan?
Hello.
Hey.
I think I'm so ready for my question to come up.
Yeah, you ready for it? I'm glad you're starting to like get it, right? You're learning a lot of linear algebra, I see, with noise too. That's pretty cool, man.
Yeah.
Awesome.
Also, would you mind looking in the chat?
What I mind? What? What do you want me to do?
I want you to look in the Twitch chat because I want to say something.
I'm looking in the Twitch chat. Ah, redeems a bond coin. Oh, redeems 2 bond coins, 3 bond coins. Wow, 4, 5, 6. Oh man, dude, 7, 8, 9, 10. You gotta stop at 10, right? Nice, dude. Wow. 10 bond coins. Wow, dude. That's a lot. Wow, you're going to be very close to 200. Oh, I do got to get you a prize soon. It's too funny, dude. The second I know how you work, Ethan, which is good. It's cool. You're a case study in like why I do what I do. Because the second you see like a goal and you see like a prize, like you really start going after it, which is cool. That's a very good characteristic to have in life. It's called motivation and drive.
What's a case study?
Case study is like an example. So for instance, when someone's like a good example of like a certain thing happening, like if I wanted to test a hypothesis, like let's say for instance, you know, if I release a new skin on Fortnite, kids will start playing more Fortnite. A case study would be like, let me look at these students, let me release a skin on Fortnite, let me see if they play more. If they do, then yeah, that's a case study. It actually, you know, case study comes from, I think like more like probability and statistics and stuff, because a case study is usually you have a theory about how like some behavior happens within people, and then you start studying it in like a group of people and you see if that holds, and then you say that, oh well, if these people do it, this means everyone else must do it as well. I know what a case study is.
All right, so I'm basically like, and for this example, I am the one who's doing a case study, just focus on the one goal.
Well, you are a case study. So for instance, if I wanted to, so my whole Discord, like, and actually the whole purpose of what I do here is, I want to incentivize you guys to do good things for yourself, which includes like learning, exercising, playing chess, like all sorts of like positive things. And I believe the way to get people your age to do it is to provide some sort of incentive. And if there's an incentive that is like real, like you can see it, you can see that it's going to happen sometime soon, you are more likely to do all the things, all the positive things necessary in order to get to that reward. And so yeah, so that's my whole Discord is a case study for that. It's a case study for like, how do you motivate kids to do well in math and science, and also just in their whole life, like, you know, exercising and stuff. And you're an example of that study proving to be, that theory to be correct, I guess. You're part of the case study. You're all part of the case study. But you're a positive result of the case study.
To what I was telling you about, like that,
About what?
the report, remember?
The report. Yes.
About
Oh, the chess thing? The chess report you want to write?
Yeah.
Yeah, that's
Yeah.
cool.
What if I did something like? Is that also a case study?
So that's more like a review. What's up, Hypatia? Good to see you.
There's something I want to show you. Like today, somehow my university decided that I needed I have to do another interview because somehow they think when I teach I tend to say things too complicatedly, let's
Oh,
say.
well, yeah. I mean,
So
sometimes, but
yeah,
you
they
teach
gave me
very
a
complicated subjects.
yeah, they gave me a topic to explain why you can use integration to calculate the volume of a cone, and I made this mathematical thing.
Oh, cool. Send it to me. Send it to me.
Yeah, it's in the office hour.
All right, let me go check it. All right. Also, Ethan, to answer your question, what you'd be writing if you're writing about like the history of chess and like the people that have played in it and like whatever, that's called more of like a review. That's called like a review article, is what that is, or there's a name for this in the scientific community, but like basically you're providing a lot of background information about a topic so that other people can read.
Survey? Do you mean a survey?
Yes, a survey. Is it kind of like a survey? You know what I'm talking
Or
about when like
literature review?
yeah, when there's like a subject that comes out, right, and then someone writes us.
Expository?
Sorry, what is it?
Expository?
No, it's say like a bunch of papers come out on a topic, and then someone basically summarizes all of the topics, and then says, here,
Compilation?
yeah, kind of like a compilation, I guess. Yeah, there's a name for it. One second. Let me look up some stuff. I want to find your thing, Hypatia, but let me. There's a name for this thing. It's called journal, like a review of current, or maybe it's just called a review paper. Review paper. I think it's just called. Yes, here we go. It's called a review paper, is what it is. Yeah, and it basically summarizes the current state of knowledge of a certain topic. Yeah.
Mathematics,
I wonder
we
if that's
usually call
Sorry.
it expository article.
Oh, that's what you call it as well? Okay. Expository article. Maybe that is. Okay, so what's up, Ethan? What were you saying?
What if I did? What if I got a role for this, like chess article person or something?
Sure, yeah, dude. I'll give. Yeah, that'd be cool. I mean, yeah, that'd be dope. Like here, yeah, write something and like maybe I'll give you some bond coins for it. I always appreciate people that take the
That'd be-
initiative on things.
That's also better. But I've been thinking about so recently. I've been thinking about that article thing so recently.
Then do
I'm
it.
like,
Yeah, do it, man. That's awesome. I would happy for you to do it, dude.
all right.
Okay, so let's see here. So Hypatia, so you're being asked to explain how you can use integrals to find the volume of a cone. Is that what you're doing? What's up, Dark?
The interviewer specifically said I have to my audience in this mock teaching thing
Sure.
is weak students, like quote unquote weak student. I don't like that word, but
Yeah, I don't like that either, but I know. They mean like not very strong in math. I mean the opposite of strong is weak. What's up, Dino? Yeah, I get it. Okay.
give me some time to talk with them. I'm sure I will be able to. There's no weak student, air quotes.
I know, weak student. That's terrible, dude. That you're already like telling kids that they suck, basically. Like what? Don't do that.
That terminology is China. In China, people use that a lot. Like
They say like weak
You're a
people.
or you are a liability to the society.
You're a
In fact,
liability to society?
Yeah, my mother called me yesterday,
Yeah, that's
telling
what.
me that I am a liability to both the United States and China now.
Oh man, you're not a liability. You're a gift. You're an asset, man. What? Like you help people. I mean, I'm a liability to myself sometimes, but but in the joking sense. What's up, Teacup? So you know what would actually be a cool Hypatia, when do you have this? Okay, so I see. So this is the Mathematica code you wrote for, right? This is what you wrote. You wrote some
so
code.
On the top, you can
This
see
is-
there are 2 sliders. If you slide it, let me
Yeah.
show you. If you slide it, what will happen here?
Yeah. Okay.
Mm.
You can share your screen.
Here.
Or wait, I have to stop sharing my screen, I think.
I can just send a screen capture.
Oh, okay, cool. Yeah, just send a screen cap. Yeah, when do you have to do this? When do you have to prove to this this panel that you can teach weak students? What's up? When is
I've
this?
done it today. I passed it.
Oh, you passed. Oh, good job. Very cool.
Yeah, look at that. So if I do the slider, you can see the delta goes
I
to
like that.
smaller and smaller. So like the Riemann sum, you can see the partitioning.
Yeah, this is very cool.
That cylinder.
So,
And then also on the right side, you can see all the numbers changes too.
I like that. I like that. Yeah, that's very cool. That's very visual. I mean, to me, it's a little technical to see all those things. But here, let me show you something. I've been one of my other jobs here is with Kudu. We've been writing kind of like a remedial math lesson type thing, and this is exactly what I've been writing, which is about multiple integrals. And so what I've been doing is, here we go. I was basically saying, okay, cool. This is how you can use like 2D two integrals to find like a volume, right? And I explain it like, yeah, here's a surface area, here's the height, right, which is dz, and then we just get dz smaller and smaller, and eventually we just add them all up. And then I literally did this example. You did a cone, I did a pyramid. This was me doing a pyramid, and I just wrote some text about it.
Too. Like here.
Yeah.
I can show you this.
Is it very easy for you to just like type something in and be like, oh, now this is a pyramid?
Yeah, it's like you just change some words and then change some code, and then the cone becomes a pyramid. Like
That's
this.
cool. Oh, whoa, you can do it that quick, dude? That's very cool. That is super cool. What? Look at that. Wow. Man, that's really dope.
Like I chose, so this is like interactive demonstration. I chose Mathematica over JavaScript because like JavaScript.
Well, it's more natural to you. It's more natural to you, probably, right? You probably code better in Mathematica.
Mathematica is that you can prototype very quickly.
That's
why actually, like yesterday, I just spent just 1 hour or two writing all of these. If
this is very cool.
I might have to spend a day or something.
Yeah, no. And I like how there's an applet, right? You can move this around and stuff. That's very cool, dude.
Yeah.
You know what'd be cool if is there a way to automate this? Automate the sliders and stuff? Like, could you make a video that like shows what happens as it gets smaller and whatnot, but like tell Mathematica to like do that slowly? Or I guess you could do a screen recording of you doing it.
Yeah, look at this. Yeah, I can just put a animation into it, but well, I only have screenshot, but you can see it.
Okay, let me see. Oh, very cool. What? Oh man, dude. Yeah, dude. This is why Mathematica is so powerful. Like what? Yeah, you can put an animator on that basically. Yeah,
next semester when I'm going to teach the reputation, I will incorporate some of these.
Oh, hell yeah.
Like, if you just draw on the blackboard this complicated thing, it look like horrible.
No. And I mean, this is why, like, you know, we should be taking advantage of technology, right? We have all this technology. We have all this cool stuff we can animate and stuff. We should 100% be using it. And I think that's very cool, Hypatia, that you took the initiative to, like, use Mathematica to write that. I might even be interested myself in like doing something with that. I don't know. Let me talk to my my company people and whatnot, and let me see what they think, because animations are super useful. I don't know if I can incorporate animations in their little textbook thing here. It's a lot of like images, but maybe there's a. Let me see. I think they allow. Let's see. Image. No. Oh, I can do an iframe. Maybe it could get saved.
You actually can with Mathematica, but probably you have to set up a server of some kind.
Right. Oh, for it to live stream and whatnot. Yeah.
Well, the thing about Mathematica is that it cannot be run in a browser. Like it doesn't have a JavaScript to try.
Yeah. No. I got you. Yeah. We'll have to see about it. All right. Here, let's start some questions off. So we're already 5:15. All right. Welcome everyone, Office Hours. My name is Dr. Gold. I'm joined by Hypatia here, and we are here to help you out with whatever math homework, science homework, life homework. Life is a bunch of homework, honestly. You got to do the work. But yeah, we're here. It's Friday. Love it. I've had a great week. I yesterday decided I'm going to Burning Man, so that's gonna be interesting. What else is happening? I don't know, just a lot of fun stuff. I'm in a good mood. Played some poker with my friends last night. I got 3rd place. Or maybe 4th, but not too bad out of like 7 people. Gold homework one day. Yeah. Okay. Noise says, I want to see Ethan's live action solution. Oh, it's the solution to system equations I just posted. Yeah. Did you do that in the linear algebra section? Noise has been really awesome here. Like big props to Noise for teaching some of the students here who on their own accord have just been like, hey man, I want to learn about linear algebra and physics and systems equations, and Noise has been super cool here to take the lead on his own. I didn't ask Noise to do this. Noise just did this, and he's been teaching him linear algebra. Dude, your handwriting is so nice, dude. My handwriting is absolute trash. Yeah. No, this is cool.
I think I have,
Yeah, what's up?
I feel like I have worse handwriting.
It's okay. My handwriting's the absolute worst. Absolute worst.
No, it's not. It's more worse than yours, though.
No way, dude. I got really bad handwriting.
Look, some people can't even understand. Okay.
Okay, well that's different then. Oh, this is cool. It's a rainbow plane. Nice. It's cool. Okay, cool. All right, sick. I appreciate that, Noise. All the work you do there. That's cool. I saw you posted you posted a probability question. So we're gonna have some fun later. Yes. Noise
I also
does.
want to learn about probability.
Yeah, we're gonna go over it. Actually, and I'm gonna have to kind of reteach myself because I forget like how Poisson distributions actually work. So it'll be a good fun time. As long as you're not too sleepy, Noise. But okay, here we got 3 questions. First one is Cuber. I appreciate all these. You know, when you guys like post things like this and whatnot, this is awesome. Like, I love the participation. I'm a big participation person. Okay, let's see. Let's get the Cuber up. What's going on, Teacup? Have you fixed your audio? Is your audio fixed? I'll have to see it is. Okay. All right, Cuber, what's up? What's up, dude?
Hi. Hello.
Hey.
Hey. All right. Yes. Teacup's mic works. Cuber's mic works. Awesome. Okay. This is we are multiplying 2 things together. Do you know what the name for these things are, Cuber? There's a special name for these. Starts with a B.
No, I don't know.
You don't know. Okay. Well, how would you describe this thing? We could call them like parentheses things or something. I don't know, right? There's parentheses things. Yeah, no, that's cool. Yeah, no. I always like to be like, you know, what would you call it? So technically, what the math term for this thing is, this is called a binomial. Have you seen that word before?
No.
No? Okay, cool. You will see the word. You will see that word eventually. I'm sure you've seen. Have you seen polynomial before?
Nope.
Nope. Okay, cool. All right, we have polynomials, we have monomials, binomials, and really just trinomials. We kind of like stop after that. Okay. You know what like mono, bi, tri means? Do you know those as prefixes? Like what does tri usually mean?
3.
3. Nice, good. Yes, this means 3, right? And then bi means 2, and mono means 1. That's where it comes from. All right. So what binomial means is that this has 2 terms. Binomial has 2 terms. Do you see how there's an x here and a minus 4?
Yeah.
That's why it's called a binomial, because you have 1 term here and 1 term here. All right. If I had something like this, let's say it was x squared plus 2x minus 6, what type of nomial would this be?
Trinomial.
Trinomial, right? Trinomial, yeah. Yes. Yeah. Yes, this is a trinomial, yeah. Noise says, ask Hypatia about polynomials. They know everything. Oh, wow. Yeah, we'll have to see.
You know who actually made up this word, like binomial?
Yeah. Tell me. Yeah, let's get some history. Who came up with the word binomial?
I think it's probably Newton or Leibniz.
Yeah. Oh, Leibniz. Yeah, Leibniz is a cool dude.
Like
But-
one day, like it's probably before the differential calculus or air quote differential calculus, but maybe in the Principia or something like that.
Sure.
Because the expansion, the
Binomial expansion,
series,
right,
the
yep.
binomial expansion, Pascal triangle. But
Yes.
actually, Pascal is before Newton, right? I think.
Really, Pascal was before Newton? I didn't know that.
I don't know.
That's cool.
You can Google that. And also, there is a thousand year before. There is this Chinese mathematician.
Yeah, the Chinese always had it like way
Yang.
before. You're like the Chinese created pasta before the Italians did. Or like, it's always a debate who came up with the noodles first.
Oh, well, it's not the same thing. We don't add eggs into our
That's
pasta.
right. It's just
into
rice.
our
It's just rice
noodle.
pasta. Yeah.
Like right now, in modern days, we just add MSG to our noodles.
Ew, no, not MSG. Bad for you. Oh man. No, it's just like he's never heard the word monomial. Yeah, monomial is totally a thing. Yeah, it means one term. One term. Okay. All right, Cuber. So these are two binomials. I need to multiply them together. Okay. So you know how to say, for instance, if I want to multiply like this together. Let's say I just wanted to do this. How would I do that?
6x minus 30.
Good. Yeah. You see how you just distributed that 6 to the x and also to the minus 5.
Yeah.
Right. Cool. All right. So what do you think you're gonna do now, if you have like two things outside here?
Wait, can you say that again?
Yeah. So how do you think we can how do you think we distribute this if we do this thing which has like two things on it?
We distribute the x and the -4.
Good. Yeah, we actually do both. Yeah. This is what they call technically FOIL, which I'm not the biggest fan of FOIL, but have you this is something you're going to see probably in your classes, FOIL. And this means first, outer, inner, last. I think is technically what it means. It's kind of like complicated. But I think what it means is like you do the you do the first term, right? And then you do the first. Okay, wait. First with first. Oh, here it is. Yeah, okay. All right. See, this is why I don't like FOIL, because I don't even remember how the acronym works. Okay. First means you multiply the first two terms together. Do you see that? Multiply that times that.
Yeah.
Okay, and then they want you to do the outer terms. The outer term would be this times this. Okay. And then the inner terms, right, would be this times this. And then they want you to do the last terms, which is this times this. Okay? Do you see how this is like really fucking confusing?
Not really.
Oh, it's not? Okay. I think it's confusing, dude, because I'm like drawing like way too many things. All right. Foil master race, no noise. Man. Okay. Okay. So yeah, we could do it this way. If you want to do it this way, like, yeah, let's do it. Okay. How would we do this? So what would this end up being? If I multiply the first thing by the first thing, what do I get?
Just x.
X what? So you have x here. Let's put this on a new sheet so like we're not like screwed up here. Right. Okay. Okay. If you multiply the first thing and the first thing, right? That's this and this. What happens when you multiply x times x?
Yeah, that's.
Not quite. You get x squared. That's what you get. So here's a little yeah. So x times x is equal to x squared. Do you remember, for instance, like what 4 squared, or let's say 4 to the third is, right? Do you know how to write 4 to the third in terms of like multiplying 4s?
4 times 4 times 4.
Good. Yeah. See how that's 4 times 4 times 4, like 3 times, right? That's what 4 cubed is. What's up, Nick?
What's up?
Oh, what's up? Yeah, good to see you.
Hello,
All right.
Can you hear me?
I can hear you too. Yes. Yeah.
All right.
Let me get this question first done, then I'll get you guys. Don't worry. All right. X times x, though, do you see how that's x squared because it's x times itself twice?
Yeah.
Okay, good. All right. This is kind of like, we'll go into this later at some point. There are exponent rules. Like, for instance, do you know what, like, x to the third times x squared is? Do you know what this is? This is x to the something. You may have not learned it yet. It's okay.
I'm not quite sure.
Okay. This ends up being x to the 3 plus 2, which is x to the 5th. This is kind of a cool thing. You'll learn this eventually. We'll go over it. And you can ask this actually as a question next time, and I'd love to show you like why this works. There's a very cool trick for why this works, because a lot of people forget all the exponent rules.
Okay.
Okay. But anyways, yeah, the first thing was this, right? X times x, that's going to be equal to x squared. Because really that's x to the first times x to the first is x squared. Okay.
Yeah.
All right, what's the outer one then? What do we do for outer?
X times 5.
So x times 5, right? Yeah, because this times this, right? Good. X times minus 5, right? And what does that equal?
Minus 5x.
Good, minus 5x. Okay, good. Now, what's the inner one? What do we do for inner?
Minus 4 times x.
Good. Right? So, that's x times minus 4. That's equal to minus 4x. Okay, and what's the last one?
Minus 4 times minus 5.
Good. And what's that?
Minus 20. Or
Mm,
no,
no.
20.
20, good. Good, okay. So now you have all these things, all right? So now we write them all in a row, because this is really x squared plus negative 5x plus negative 4x plus 20. Now we should simplify this. You know how to simplify this?
We can add the 5x, minus 5x, and the minus 4x.
Very good. Very good. Yep. What do we get there?
Minus 9x.
Good. Nice. Good. Now I have x squared. So plus negative is just minus, so we're going to say minus 9x plus 20, okay? And you are done. Good job, dude.
Okay.
Yeah. So that's one way to do it. Let me show you like a super quick way. This is how I like to do it. Have you taken biology yet, Cuber?
No.
Okay. When you get to biology, you're going to do something called like Punnett squares, which are good for, like, for genetics and stuff. So what I do is I end up just putting one of the terms up here, okay, x and negative 4, and I put the other term here, x and negative 5, all right? And then what I do is I fill out what all the intersections are, okay? Yeah, this is x and x. So this is going to be x squared. And then this and this is going to be negative 4x.
Oh.
Okay. And then I do
Yeah,
this
I've
and
kinda
this,
seen this.
right? Minus 5x. And then I do this one and this one. And then this is 20. Yes, phenotypes. Yes. Yes, good. And then this is the same shit, right? Because then I just combine these, right? And this is x squared minus 9x plus 20. You get the same answer. I feel like this is faster. And also, when we start getting to more complicated things, so if I have, for instance, like x plus 2 times like x squared plus 3x plus 4, now the whole FOIL thing doesn't really work, right? Because now I got to do this times this times this and this times this times this, right? So this is where it's cool to just have, you know, to just have them up like this. It's just very fast. I just do this, you know, this, you know, and we're all done. Yeah. Just a little trick, you know. They're all cool stuff. But nice. Good job, Cuber. That's a great question. Yeah, ask me about exponents next time, if you want. Or if you have something else you want to learn, that's totally cool as well. But I think you would benefit from us going over, and I know a lot of people in this server would also benefit from going over exponent rules.
Okay.
Cool. All right. Have a great weekend, Cuber. And yeah, just live it up. All right. Let's see. Next question on the docket. Teacup says, "Are we doing my question from last? Wait, didn't we do your question last time? I'm pretty sure we did it. That's what. Yeah, we did. We did. It was this one. I mean, I guess there are other parts to it we could do. We didn't finish it all. Yes, you're right. We didn't finish it all. Yes. Let me see. Well, let me see if I. Yeah. I gotta think about this. Yeah, let me get back to that. Sorry, I can't look at it like that quickly and determine whether we can do it. I think we can. All right, Ethan, what's up? Let's do some physics, Ethan. Cool. What's up? You here?
Hello? So,
Yeah.
Is my mic good?
Your mic
good
is
now?
great. Yeah. What? Yeah, this mic is awesome. What'd you do?
I switched devices to
Oh
from
my God.
tablet to my computer.
Oh, thank you. Can you please always come on the stream like this, please? It's just.
I would love to say yes, but sadly I can't. Like
Oh.
definitely not on Mondays because like my dad owns his computer for his work and
Oh,
like,
okay.
he
Oh, that's
can't
cool.
come back a tree. He can't
I-
come back a tree for me to get to office hours.
Oh, I see. Oh, you have to like, your dad has to like drive you home to like show up to our
No,
streams.
that's what happens when I go to school. That's what happens when I have to go to school.
I
Like,
see.
yes, and I stay there for like about 2 hours and then we go home.
Oh, I see. Oh, you stay at work. Oh, sorry. You're at your dad's office right now. Is that what it is? Sorry.
No, that's what happens when I'm at school. Right now, since it's summer, I am just staying home.
Gotcha. Okay. But when you're at school,
Also-
you join office hours from school, is what you're saying, and you're on your tablet.
It's like sometimes I can't make it on Monday because I'm at my dad's work and I can't use his devices to actually
Gotcha.
get
Totally.
to office hours. So that's why before I can attend.
Okay, that makes sense. Well, I appreciate you trying. I appreciate you doing everything. That's really dope, man. That like, try as much as you can to show up and learn. That's super cool. You're gonna go very far in life, Ethan, dude. I know you will. I'm curious. I'm excited to see what happens in like 10, 15 years.
Hopefully, I live one of the best lives.
Yeah. Yes. Yeah. Well, let's help you get there. Yeah. Nice. But you can always attend on your. You say you always use your tablet, right? To at least to log on sometimes.
Yes, but then sometimes my tablet doesn't have the best audio. That's why
I
you
know.
hear
Yeah.
a
Yeah. So
lot
what
of-
type of tablet do you have? Is it an Android tablet?
It's a Galaxy Tab A8. That's the specific type.
Okay, cool. So if I got you, for instance, like some headphones that have a mic built into it, I think that would like, you could plug it into your tablet and then you would be able to have really good mic quality and also you'd be able to hear the stream well and then we wouldn't hear the stream in your mic. I think that's what would happen.
All right.
That'd be cool. All right. No, just good to, just good to know. I like to know how you guys, interact with us on Twitch. That's cool.
But also, Dr.
What's up, dude?
Since I'm getting my visa, we are actually going to go to Colorado in the U.S.
Oh, hell yeah. I like Colorado. Well, let me know when you're going. Maybe I'll be in Colorado. I don't know. I'm in Los Angeles, but sometimes I go to Colorado. Maybe we can do the first actual education meet and greet. I don't think I've ever met anyone in this server in person. It's interesting.
What? No way.
Yeah.
Out of 1,000 people here?
Well, besides Al Prince and Bon and A-Rod, besides the mods or the TAs, sorry, I have not met anybody. I have not met any of the students in person. Yeah.
I hope you meet like a class rep.
Yeah. PC37X, I heard. Yeah, that's. Yeah. Yeah. What about Sam? I haven't met Sam in person. I've been to Sam's house, but I haven't met him.
Oh.
That's always the funny one. He's always out of town when I'm dropping gifts off, and I'm like, okay. I've never actually seen Sam. Although yeah. I know Sam exists. What's up? What's up, Ethan?
If I actually get to see you in person, I might consider myself lucky.
Oh, that's dope, dude. Yeah, no, I think that'd be cool. Be cool to see how
Because-
the internet works. Yeah. What were you gonna say?
I feel like I am one of the luckiest people, maybe. Or
Yeah?
People that can get out of situations because sometimes teachers will also have pity on me for despite me doing bad stuff, and they would give me a second chance. Or
That's
at
good,
least
dude.
increase my grade.
Yeah, dude. I believe everyone deserves a second chance. I believe everyone. We all do. We all make mistakes and whatnot, or like we don't get stuff the first time.
Yeah.
But I'm incredibly patient, as you guys saw today with. God damn it, Taco Cat's really like testing my patience. I had to put him in detention. I had to.
Really, please don't do that, okay? Please don't do it.
I know. Well, I try a lot of
Just
different
one
ways
thing.
of getting people to listen and understand, and then something will work eventually.
Okay, man.
Yeah, that's all
But
good.
you know, Dr. Go, the
Yeah.
whole reason I was doing this is to actually get the little article I was writing on right now. But we can
Yeah.
stop for now. I can stop for now.
Yeah, no, that's cool. No, it's all good. Yeah, no, the chess article you're doing is good. I'd be happy for you to do a chess article.
You don't even know what I'm even typing.
Wait, where are you typing? Where are you typing something?
No, I'm actually typing in the article right now, so you can't see it. But
Okay, that's very cool. Yeah. Do you want to do your question now, or do you want to keep typing? We can do your question later. Like, what do you want to do?
No, I want to get this done now.
All right, let's do it.
I want to see, I'm trying to see how I can actually drive through this, like
Yeah,
getting
let's
to your
see.
final destination.
Let's see it. Let's do it. Let's see if we can do it. Okay. In the figure, a frictionless roller coaster of a mass 812 tops the first hill with a speed of that, and at that height, okay, 45. What is the speed of the car at point A? That's pretty cool. This is a fun question, actually.
And it
All right.
actually kind of makes it easier for me because I know if the gravity is actually negative or positive.
Okay. Gravity is always
So-
pointing down, but when we use it in the potential energy equation, it's a positive number.
All right. So let me try and get everything correct in detail.
Let's do it.
So
Let's do it.
basically what I gotta do is that we know kinetic energy and potential energy. Kinetic energy is when it focuses on speed, and potential energy is when it focuses on the height.
Good. Yes.
And so these two energies have formulas that we use, which is like K. That's all.
Yeah. Keep going. You're good.
Would you mind writing it down? The formula.
Yeah. No, I will. Yeah. Sam. You're good.
So it's gonna be Ke for kinetic energy is
Good.
equal to 1/2 times the mass times velocity squared, v squared.
Nice. Good job.
And so the next one is potential energy, where it's UE
Good.
is equal to mass times gravity times height.
Nice.
Nice.
And so basically we gotta use the information that we know of. And also we need to use a specific topic in this for this equation, or
Yes.
for this thing called conservation of energy. And just to give a little information is
Yeah.
that
Yeah. Tell us.
the total is that in conservation of energy, the total energy before and after needs to be the same.
Yes.
So
Exactly.
it's like for point A, for point B, and point C, they must all be the same.
So what must be the same?
Like the total energy. The
Total energy. Good. The total energy. Total energy is very good, Ethan. Yeah. The total energy is always the same.
And so basically we gotta solve this by using the formulas that we have.
Yes.
So it's like we know that Ke is like for like I think we do it for the first hill, right?
Uh-huh.
So it's like, what if we use like a different variable, like FC for FH for first hill?
Yeah. Let's do first hill. FH. That's fine. Let's do it.
So basically it's like we use kinetic energy and potential energy for this. So it's like Ke is equal to 1/2.
Good.
And we know that the mass for this is 812, right?
Very good.
And we know that the we know that the velocity is 19.
Good.
And so we gotta also find out the potential energy.
Very good. So this is 19 squared. Good. So let's do the potential energy too.
So like before, we already know that the mass is 812,
Good.
and we know that the this
Yeah.
is pretty obvious.
Yeah.
It
Right.
says
The
it right
gravity.
there.
It does.
Gravity
Right.
is 9.81.
Good.
And for noise here, do not use 10.
Don't use 10. Don't do it. I know Noise wants to do it. Don't do it.
Let's not go on that evil route here.
Yeah, that's evil, dude. Okay, cool. Yeah, it's good.
And we-
9.81.
Times the height, which is 45 meters.
Very good.
So we gotta solve for what we know.
Yes. Right here, we can get numbers for these if you want. Oh, we can. Cool.
Yeah.
I'm going to
So
show you a
19
shortcut
squared is
after
like
this,
361.
but yeah, let's do it this way.
What's it go?
Yeah.
19 squared is 361.
Oh, is it? Okay, that's cool. 361?
Yeah.
I believe that. Okay.
Yeah.
361 times 812 times 1/2. Okay. That's 146,566.
Is that joules?
That is in joules. Very good. It's energy. Good. Okay.
We know that. And can I also say something here?
Yeah, please. Yeah, say it, dude.
It's like joules is like it like focuses on energy, so it's like it doesn't matter which energy, if it's kinetic energy, potential energy, whatever spring energy is, it's always in joules.
Yeah, that's good. Yeah,
And
all types of
so-
energies are in joules. Yep, very good.
I don't know what spring energy is,
We'll go over that. That's a different question. Yeah, we can go over that later. You'll get to that. If you keep going through these physics topics, we're eventually going to get to like spring potential energy.
All right. And then we gotta solve for the potential energy for FH.
Good. Yes. So let's do that on the calculator, right?
Yeah.
Let's do 812 times 9.81 times 45. Okay, good. And that's 358,457. 457 joules.
Joules.
Good.
Also, I also have my own calculator for this, so I'm also solving it as you go along.
Oh, nice. That's good. I love calculators. I'm a big fan of calculators.
Honestly, this one is scientific.
That's cool. Yeah, scientific means I think that it has like the E function on it, so you can. I think you can do this. If something's scientific, you can do this. Like for instance, 5e to the 5. This puts 5 with 5 zeros behind it. That's what it does.
I don't get that. Maybe that's
Yeah.
a different math topic.
That's called scientific notation. Yeah, we can do that at another point. That's another good thing to know.
Is it sci-fi, like science fiction?
No, scientific notation is what it's called.
Oh yeah, okay.
Mhm.
And so we basically have to figure out what is A now. So we also got to do like A, right?
Okay, yeah. So you want to call this one FA? Is that what you want to call it? You want to call it FA?
I think we could just do A.
Okay, let's just do A. That's cool.
And also, can I say a little side note here for
Yeah,
for,
a little side note. Let's do it. Yeah, let's do it.
I hope you understand this, but here we go. It's like a lot of the times in physics is that we know that the total energy in one spot and for the other spot are the same,
Yes.
but we don't know the parts. But we don't know some of the parts for that one spot.
Exactly. Very good. Yes. So for instance, in this case, right, on the first hill, we knew the height, right? And we knew the speed. So we knew everything. But
And we knew the
here,
velocity as well.
and we knew the velocity. Very good. Here we don't know what the velocity is. We're solving for it, right?
No.
Yeah.
And so we're trying to find that.
Yeah.
And so we basically use the two same formulas again, which
Good.
is Ke is equal to half
KE.
times 812.
Good.
And this remains as V squared since we don't know what that is.
Very good. Okay.
And then we got potential energy, which is UE is equal to
Good.
812 times 9.81.
Yep.
And times the same height for the 5.
Yes. Good.
And so we already know like the potential energy immediately.
Yes. Yeah. Because this is the
it's like-
same stuff, right? Yeah. We've already done these numbers, right? Yeah. Good.
But
Nice.
This one is different, but this one for A is different.
Well, the potential energy is going to be the same, right? So this is still going to be 358,457. Okay.
And then what we basically have to do is to like solve the. Let me figure this out by myself.
Yeah, do it. Go for it. So what are you doing? What are you doing here, Ethan, when you say you're figuring out yourself? What are you doing?
Like I'm trying to figure out what's half times 812, which is 406.
Okay. Yeah, good.
406 V squared to be exact.
406. Yeah, good. So this is technically 406 V squared.
And so this is when like I said before, is that these two have to be the same.
Yes. What has to be the same?
So then we like the total energy has to be
Total
the same.
energy. Go total, right? So we got to get the total energy first, right? So what are we doing?
And so we basically we're supposed to now like try to subtract them to the lowest we can.
Mm-hmm.
And so we gotta take like the total energy in the first one and subtract it with the total energy in the second one.
We want to equate them. We want the total energy in the first one to equal the total energy in the second one. And you're right. We are going to probably start subtracting some things. Okay?
Yeah.
All right. So
we
what?
basically like
Yeah. Keep going. You got it.
So for the first one, I think we do like 358k minus 136k.
So we're gonna add it, is what we're gonna do. We're gonna add these two
All right,
together
because
because we
they're
want the
same.
total.
They're the same.
Yeah, you want to add them, yeah, because they're total. You want to add the total. So that's
And also,
gonna.
like,
Yeah.
See, I think this is all of the physics stuff out of the way. We just have math now, baby
We
math.
do have just math. I'll show you. There is a. You could use physics to make this even simpler, but yes, let's do it. So we're gonna add these two together. So this is 505.023.4, right?
Okay. And so I think we got to like also add. Wait, no, we can't add this because this is different. I think we gotta
Right.
multiply maybe.
So wait. So if I add, I
Oh,
want
no,
the
no, no,
total. Yeah, keep going. You got it.
Wait, I forgot. I think I got this. Like you
Got it.
gotta put like 358k minus 406 v squared, right?
Plus 406 v squared.
All right, yeah, plus 406.
You add these. You want the total energy. Total energy means add them up. Add them up. Okay.
Yes, and then this is basically simple. We want the 406 v squared by itself, so we subtract 35847 on both sides.
Good. Yep. Very good. I'm gonna subtract this. All right. So minus. Good. So that's gonna go away. Goodbye. And then this is gonna become, what is that? 146,566. Good. Is equal to 406 v squared. Okay. Then what do we do?
And then we want v squared by itself, so we gotta divide. Now we gotta divide 406 on both sides,
Good. Let's do it.
which is 361 for the other side, right? Like do it out yourself.
It's 361. Yeah. Yeah. No, I believe it.
Right.
I believe it is. I believe it is.
All right, and then the last step is square rooting both sides, which is already automatically 19, right?
Yeah, it's good. Because you remember 19 squared was 361?
Yes, I just immediately remembered it in my head.
Nice.
And we're
Good.
done.
And we're done. Nice. Good job. Good job, Ethan.
Let me see something.
You did that like all by yourself. That's very cool, Ethan. That's dope. Yeah.
Can I say something?
Yeah, you say something. What's up?
Well, I think I went into every single detail possible. I don't know what else I can say.
Yeah, no, you did. And so what you did, Ethan, is very good because you explained all your steps. This is what happens when you teach, is every time you do something, you explain, well, this is why I do this, and this is, and what's very cool is like, you took all the information we learned in Wednesday's lesson, and you remembered it, which is very cool. Like, this was the one when we did it on Wednesday.
That's the goal.
Yeah.
I basically like wrote the information down so I could try to explain it like a teacher.
Oh, good. That's awesome. That's really cool, man. Yeah. And I mean, Yeah, go on.
I told you I'm determined to at least try and be smart. So
yeah,
that's the
there you-
best of my abilities I could go to.
Yeah, here. So now, let me show you something that's even cooler. Do you notice how the speed is the same?
Yeah.
Okay. So this is a key thing in physics. So like you could have skipped all this math if you recognize something key here, which is that, let's remember energy, right, is always like kinetic energy and potential energy, right?
That's a goal? Wait, is that a goal?
Yeah.
Does it have something to do with these two hills being the exact same height?
Yes, exactly. Okay. So when this whatever this object, right? I don't know what this is. Oh, it's a roller coaster car, right? Goes all the way down and then comes right back up to the same height. The potential energy will not have changed, right? The potential energy will be the same. Okay.
Yeah.
Remember that the total always has to be the same. So if this is the same and the total is the same, what does that tell you about the kinetic energy? Did it change?
What? Wait, say that again.
Okay, so if the total energy is always the same, okay, and potential energy does not change, does kinetic energy change?
Of course not, right?
Good, yeah, exactly. And if the kinetic energy does not change, that means the speed does not change. Because remember, velocity is a big part of kinetic energy.
Yeah, since it focuses on the speed.
Yes, good, yes. So that's how you could have seen this right away and just been like, oh, cool, it's 19 here. I mean, I like what you did here. This is good to explain all the steps, but that's another way you could have done it. And also, like, here's something you would have seen here, which is pretty cool, Ethan. You see how we did all this math here and whatnot, right?
Yeah, we did. We did.
Okay. So look what would have happened if I didn't. This is why I know you guys love to do things on the calculator, right? You love to like you want numbers. I know you guys want numbers all the time, but it's useful sometimes not to compute the numbers because then you can see when things cancel out really quickly. Okay. So
How do they cancel out?
I'll show you. So when we were calculating total energy, right? You remember we got like two numbers here and we added them up. We got right 146,566 plus 358,457.
Yeah, into this 50502.
So let's not add them up yet. And then what do we have here, right? We had 358,457, right? Plus
Wait, that's 6-4, not 8-4.
is this supposed to, no, this is 8. This is 8, I think. 358,4.
But then isn't there a 6 you have in the 3-5?
Oh, there you go. 358,457. Does that make sense? Do you see that? I think it's an 8. Okay. And then this was plus, right? 406 v squared, right? You should already see that, like, this is already just going to cancel out right away. So, right? So then you would have been already at this step, okay? Now, look what happens if I didn't even calculate these. Watch what happens, okay? Let's say, for instance, that I don't even calculate this 146 or this 358. Let's just say I do this. Let's say I do 1/2 812 19 squared plus 812 9.81 times 45, right?
Okay, what is all of this mess?
Well, that's what these things are, right? So instead of getting the numbers and adding them up, I'm just keeping the terms and adding them. Okay?
All right.
Okay. And then let's do the ones here. Okay. So then this was 1/2 812 v squared, right? Plus 812 9.81 times 45, right? Because that's adding these together, but not doing the math yet. Okay.
All right.
And then what you should notice, right, is that look, this thing right here, this thing right here is the same thing as the thing right here, right?
So we already know that it's the same number. We don't gotta calculate.
So we don't even gotta calculate it, right? Yeah, we can just get rid of it, okay? And then look here. This is 1/2 times 812 times 19 squared needs to equal 1/2 times 812 times something squared. Do you see how these can also go away? Is this the same thing on both sides? So now I'm just left with 19 squared is v squared, and now you know v is just 19.
Yeah. And then
You see how
gotta square both sides.
well, you don't even have to square both sides. Well, because now you see, right? You see that 19 squared is equal to v squared, and you're like, what's v then? V has to be 19.
Because we know that 19 squared is like 361, so it's like 361 is equal to
V squared. But the square root
And
of
then we already
361 is just 19. Yeah.
Yes, that like I can't believe there was that trick hidden inside the entire time and I didn't know.
It's okay. I mean, that's why I wanted to show it to you. Like the way you did it is correct, and will work if. And it's the only way you can do it if, for instance, the height changes. The height changes, you have to do all the math. Okay. But if the height is the same, and let's say you didn't like do the math here, like these big numbers and whatnot, you would see that these things cancel right off the bat, and then you don't have to calculate anything.
Yeah, literally. Like maybe this is the easiest one I've seen so far. Like,
Yes.
it's just cancellation.
Yes. Yes,
But
it
hey-
is.
But that's okay.
Yes.
I think I've known everything about this. After I explained everything in detail and what you told me during the Wednesday stream,
Yeah.
I don't think I need to learn much more about this.
No, I think you're good on here. Yeah. So let's get for your next question. Get something different with physics, and then I'll show you how this still plays a part with other things.
But then, which subject would you want me to search them? Because I don't know much.
Yeah. No. Good. After this is let me think. Let's do something with a spring. I think. Right.
Spring energy?
Yeah. Spring energy. Yeah. Let's do this. Yeah. Do something with a spring. Do anything. Do something with Do something with the forces of springs first, and then we'll look at something with like the conservation of energy with springs. I like that. Yeah. Noise says get some math.
That's dope.
Yeah, but I kind of like teaching physics to Ethan. Math, you can teach math to Ethan. Let me teach him physics. You teach him math.
Got to go.
What's up?
So I immediately searched up the force of spring energy, and it says here Hooke's law is like F is equal to negative kx.
Yeah, get stuff like that. That's good. Yeah, like things that are hanging from a ceiling or something. Those are good questions. Or like how much does the spring stretch or whatnot? Yeah, those are all good things. Yeah.
Like what should I search up?
Yeah, that's good. Look up yeah, just look up Hooke's law questions or like conservation of energy questions. What game are we gonna play? We're gonna play Roblox. Play Roblox today.
I actually kind of want to change the game since I want to go back a little into gaming with you.
Okay,
all.
cool. Yeah. Let us play
So
one
I'm-
Roblox.
So I'll switch it up to Fortnite.
Oh, that's cool. Okay, we're gonna play Fortnite later then. Well, we're gonna play at least one Roblox game, and then yeah, we'll switch to Fortnite. Cool. All right, let me get through some questions. Very good job, Ethan. Let me give you your bond coin for that. That's dope. And then yeah, I want to get through all these questions because I want to play Roblox with you guys and Fortnite, and I also want to go to the gym because the gym is closing. I know life is a lot of stuff.
It is almost like 6 for you.
Yeah,
Also,
it's
I got
gym closes at 9 here. What's up? Yeah.
After what you watched in the beginning today, that should say 1-7 to 1, not 1-6 to 1.
Oh, I see. Yeah. All good. Sam says he hasn't played Roblox in forever. Yeah, come play. We were playing Arsenal. Arsenal was pretty fun. I liked Arsenal. Play some Arsenal. What's his face? Shaq is goated at Arsenal.
He's like going on everything, huh?
You have 2 million Robux? Dude, Sam, what are you doing with 2 million Robux? Excuse me? The hell? How'd you get 2 million Robux? What type of scam are you running here, dog? You should donate some to me, dude. Holy shit. What? Dude, how does he...
What did Sam type this?
How does he have 2 million Robux?
I know someone who has like 100 million, and then
How?
someone was like 1 million in CS:GO.
Bro, what? That's like serious cash. Isn't it? That's like tens of thousands of dollars. Damn. That's crazy. All right, where's Noise's question? Okay. Noise! Let's learn about Poisson distributions. Yeah. And then we'll do teacups. I got you, teacups. Don't worry. Your gym isn't 24 hours. Unfortunately not. I wish it was. Closes at 9, and I need at least 2 hours to work out, so we're burning through time. Hate that, dude. I do too, man. I would work out late as fuck if I could, but the gym isn't open. Okay, Rowan and Alex are both check-in assistants for the same airline. The number of passengers are checked in by why do I care about Rowan and Alex? Why do I care about their names? I'm curious here. During a 30-minute period can be modeled by a Poisson distribution with a mean of 28. Calculate the probability that Rowan checks in greater than or equal to 23 people. This is cool. First part is easy. Yeah, well, maybe let's... Can I remind myself what, like, even a Poisson distribution is, dude? Poisson distribution. Okay, cool. Okay, Poisson distribution expresses the probability of a given number of events occurring in a fixed interval of time and space if these events occur with a known constant mean rate. Okay. Wikipedia always makes things so complicated. So complicated. Like, what's all this, like, math jargon, dude? I don't want this. Like, get out of here. Go away. Okay, here we go. All right. A discrete random variable is said to have a Poisson distribution with a parameter gamma is greater than 0. Has a probability mass function given by that. Okay, cool. I like this. Is equal to the expected value of x. Also, its variance. Is gamma the rate, Noise? Oh, lambda is the rate. Okay, very cool. Very cool. I like that. There you go. Okay, good. That's what I needed. Where's my... Let's get this. I love how they say, like, what E is. Like, I know what E is. Excuse me. Bom. Okay, cool. Right, okay. So yeah, probability, right? You know, is basically like what's the chance of something happening? You know, I actually did a lot of probability last night when I was playing poker. A lot of times, like certain cards would come out, and I'd be like, what's the probability that, for instance, Alex has a better card than I do? And like, what's the probability that the card I need to come out in order for me to win will come out? So there's probability is super useful. It's very cool. They do this a lot in the airlines. Have you ever noticed that a lot of times you go to like get on a flight and they say we're looking for volunteers to not get on this flight and we'll give you like $100 or something, which is like dope. The reason why this is airlines know they overbook their flights. Yeah, and the reason why they overbook their flights is they know a certain number of people are not gonna show up. They know they can calculate the probability that people are gonna miss their flight. And if they miss their flight, they don't want to have an empty seat. So they on purpose will overbook flights because they know somebody's going to cancel or somebody's not going to show up or someone's going to screw up. Yeah. It does happen a lot more in America than Europe. Yeah, probably because there are bigger penalties in Europe for it. In America, you know, we're just like, fuck people. We love money. You know? Or companies and corporations. So yeah, it is a big problem in America sometimes. Yeah, but you know, they've done the numbers. And for whatever reason, it makes the airlines more money to overbook flights and pay people if it's full than to just leave the seats open. Yeah. Anyways, so a Poisson distribution kind of goes into that, and it's a way of calculating the probability of a certain number of things happening. Okay, so in this case, they're saying that Rowan checks in 28 people every 30 minutes, okay? Yes, cool. 28 people every 30 minutes. And they want to know what's the probability that Rowan checks in more than 23 people. Wait, so this is like on average. On average, he checks in 28 people every 30 minutes, okay? And we want to know what's the probability that he checks in more than 23 people. Because, you know, sometimes he'll check in 29, sometimes you'll check in 22, right? So there's some variation in it. And if it's a Poisson distribution is a certain type of, like, you could say like probability graph or something. It's technically called a probability distribution function. It's called a PDF, or probability mass function. Is that what they call it? I call it probability density function. They call it mass function. I guess it's okay. Yeah. Okay. So in this case, it's lambda, where lambda is, you said the rate, right? So lambda, so if it's 28 every 30 minutes, right? Then the rate is 28 over 30, right? Is that what lambda is, Noise? Is that right? 28 over 30? Equal to lambda? That's how many, like, per minute, right? And then k is the number of occurrences. So I want the probability. Oh, I see. That. Oh, I'd have to add these all up to infinity, though, wouldn't I? Oh, that's not good. Right? I think Noise, right? I'd have to add this. I'd have to do the probability of like 24 plus 25. Or actually, I really have to do 1 minus the probability that it's less than 20, or less than or equal to 22, right? Or less than 23. Lambda's just 28? I guess so, because you're just calling this like a block of time. You say time. Oh, because it's always a 30-minute period. Okay, but I see. Sometimes it's a 60-minute period. Aha. Yes, good. Okay, yeah. 1 minus the probability that R is less than or equal to 23. I think it's less than 23, not just less than or equal to, because this says the probability R is greater than or equal to 23. Right? It's gotta be you can't overlap on the equals. Oh, less than or equal to 22. Yes, good. Okay, cool. Yes. So there are calculators for this. Actually, I think you can do this on a TI-84. Let me see. I'm actually curious. I go to statistics. Is it in there? Do they have the distributions? No. They have that. They got chi-squared tests. Where's Poisson? No. Oh, here we go. It's in probability. I think this is it. No, it's and choose R. No. Man, they don't have a Poisson thing in here, dude. That's kind of whack. Whatever. I saw chi-squared. Ew. What's up, Ethan? I could have sworn you can do a Poisson distribution in this. Where is it? Yeah, there's a Poisson PDF command. Where is it? Where is this thing? No, not in that. Ew. What's that calculator? Excuse me. What? Ugh. Where is it? Just show me the buttons. Ah, it's in distribution. But where is that? Okay. Let's find it. I know it's somewhere. Oh, here it is. Got it. Noise. Watch this. Second distribution. There we go. Got it. That's cool. Poisson. Cool. And then CDF means it's gonna add it all up from some value to some value. So here we're gonna do CDF, and then this is 28, and then the X value is 22 because we want to go all the way up to 22. Yeah. Cool. So it's that, right? Yeah, cumulative, right? Yeah. So then we do 1 minus that, right? And so that's an 85% chance. Cool. Is that right? Do we have the answers to these, Noise? I always like to double check my probability. I'm a little shaky on it sometimes. Yeah, okay. Okay, the number of passengers A checked in by Alex during a 30-minute period can be rolled by a Poisson distribution with a mean of 16. A randomly selected 30-minute period is chosen. Calculate the probability that exactly 42 passengers in total are checked in by Rowan and Alex. It's from the exam I failed? Oh, no, Noise. No failing exams. It's okay. Yeah, so shite, yeah. Okay. This is interesting. So this is two things that are happening, right? Oh, it's like a double distribution. Okay. So I need... Oh, that exactly 42 are checked in. Okay. Wow, this is a little tough. Am I going to calculate all the probabilities here? Am I going to do like Alex checks in 42 and then Rowan checks in 0, then Alex checks in 41 and Rowan checks in 1? The first one's right? Good. I'm glad I know simple ones. Okay. What about this second one here? This is a joint thing. We have two things happening, and I need to know the probability that the total of them is exactly 42. Like, again, this is the geo, like, brute force method of doing it, where, like, I could calculate what each one of these is and sum it all up. But, dude, that would suck. There's gotta be a joint probability on this one. Let me think. Joint Poisson distribution. Or maybe it's compound. Yes, love it. Here we go. Compound. Oh no. Oh no. Oh no, 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 no. See, I shit myself in the mind, and I shit myself in the mind in the exam, and I fucked it. Oh, that's okay. Sorry, dude. Oh man, this is gonna. Oh god, what? No. I just want to add two things, man. I just add two things. Sum of independent with a number of no, that's not what I want. Oh, you just add them? Really? I think we can just do R is equal to Poisson 28 plus... Yes. R is Poisson 28. A is Poisson 16. Yes. And then what does that do? Oh, we get a different rate function. Oh. X equals Poisson 44. Okay. And then, sorry, what are we doing with the R and the A then, Noise? Show me. I agree. I agree that R is the Poisson distribution of 28. And then A is a Poisson distribution of 16. And then, yeah, I'm trying to figure out X is... Wait, X is... Oh, that is so cool. Oh, I see what you're saying. Oh, this is cool. Okay, so this is cool, guys. So, the distribution that describes the sum of these two, so these two working together, is a Poisson distribution of 28 plus 16. Oh, that is so cool. I didn't realize that. There's probably some math behind that, but that's cool. I see. 44. Okay, so then we just need to do a Poisson of 44 exactly at 42. Wow. They did not teach that to me in stats. Yeah, okay, so in that case, we're just going to go Poisson PDF, and then this is 44, and then the X value is 42. Cool. And that's 5.9%. Wow, very cool. 5.9%. All right, nice, cool, awesome. We're boogieing. Okay, let's see. Let's see how this is going to get harder. I know this is going to get harder. Okay. The company manager is investigating the rate at which passengers checked in. He randomly selects 150 non-overlapping 60-minute periods and records the total number of passengers checked in by both Rowan and Alex in each of these 60. Using Poisson approximation, find the probability that for at least 25... Oh man, this is a distribution of distributions? Oh, this hurts. No, it's why you choose violence for Friday, dude. What? Why is there violence on a Friday? Alright, okay, alright. Okay. For at least 25 of these 60-minute periods, they check in fewer than 80 total passengers. You said it's a Poisson approximation? Oh, okay. Okay, we assume by the central limit theorem that it's normal, is what it is. Why approximate when you can get the answer? Yeah, that's funny. Okay. Very cool. Yeah, okay. So yeah, this is the normal. Yeah, no, it's okay. Central limit theorem. Yeah. You haven't done the central limit theorem? Okay, this is a cool thing. Okay, so let me just explain what central limit theorem is real quick, because that's a very important thing. So CLT, central limit theorem, not critical race theorem, or I don't know, whatever theorems they're like yelling about in politics. What this says is that if you do something enough times, if like you keep trying to do something, if you do it an infinitely large amount of times, eventually the distribution of what happens ends up looking like a normal distribution, which is a bell curve, okay? Which is something like this. So it says if you do something enough times, eventually it will look like a bell curve, which will be centered around some mean, and we'll have some standard deviation. CLT more like THC, yeah. So, say for instance you were, I don't know, yeah, I'm trying to think here. Okay. Let's say I was baking cookies, okay? And then every time I baked the cookies, I saw how many of the cookies were delicious, you know? And let's say I cooked the first batch and there's like 6 that are delicious. I cooked the second batch, 8 are delicious. Cook the next batch, I don't know, I burn all of them, so none of them are delicious. These would all be numbers, right? Let's say like we have like cookies or like trials, right? So I could say, oh, you know, I have 0 or I have 8 that are good, 6 that are good, 5 that are good, blah, 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 blah. If eventually you cooked enough cookies and just like kept cooking cookies like forever and whatnot, eventually, and you graphed, for instance, you know, like how many cookies were good, how many times, like say like, I don't know, 0 cookies were good like this many times, and then 1 cookie was good this amount of time, and then I don't know, like 2 cookies were good this amount of time. Eventually, this distribution, this shape would look like a bell curve, and it would have a mean and a standard deviation. And more importantly, it's a normal curve, which means now we can use all sorts of wonderful things such as z-tests and t-tests to calculate the probability of something happening. Yeah, it's very cool. Yeah, okay, all right. So in this question, right, we're gonna say that we check 150 flights, right? And I want to know the probability that for at least 25 of them, they check in. Oh, by Rowan and Alex. Okay, so first of all, we know this is Poisson 44, right? We've determined Rowan and Alex together are a Poisson 44 distribution. Okay. And that's going to be cool. That's going to be a, we can get then a normal approximation for that. Okay. So mu is equal to the rate times the size. Okay. So in that case, the rate is 44. What is the size? Is the size a... Wait. So normal lambda times n. Why are they doing Poisson? Okay. And n is the number of trials. Okay, very cool. So this was 100 trials, right? Okay. Very cool, very cool, very cool. So this ends, so this is lambda. N is equal to the number of trials. You did it with a binomial distribution? No, I think you can do it with the normal distribution. This is 100 trials. Or it's 150 trials, right? Because I do 150 flights, right? Okay. So that tells me that mu is equal to 44 times 150. Okay, cool. That's 6,600. Well, I should know that. Okay, 6,600. All right, that's our mean. And then our standard deviation, right, is standard deviation. Square root of lambda times n. Oh, that's cool. So and that's the square root of this. Okay, square root of that. 81.2. Okay, cool. All right, and this is equal to 81.2. All right, so let's see what this is. Okay. Okay. Yeah, I think this. Yeah, wait, because it says for at least 25 of these. Checking a fewer than 80. Oh, yeah, you can do binomial. No, you can do binomial for this too. Sorry. This is what we're gonna use this for this, but here I am gonna use binomial for this. Okay. So I need to find first of all, what is the singular probability of the reason why it's binomial is because you either have a success or a failure noise. You either check in fewer than 80 passengers or you don't check in fewer than 80 passengers, okay? That's why it's binomial, because it's either pass or fail. And so what I need to do is figure out, okay, what's the probability they check in less than 80 if it's a Poisson 44? So that's going to go to Poisson. Man, you British people have like some complicated exams, dog. What? Excuse me? 44, 80. Very cool. Well, that's like 100%. Yeah, what? Probably for at least 25? Okay. Yeah, because what? Rowan checks in 23. No, sorry, 28, 16, 44. Rowan and Alex check in. Yeah, well, okay, that's gonna be huge. Okay, it's basically 1. You see that noise? The probability is basically 1. Okay, but whatever. We'll roll with it. Okay. So then the probability that this is a binomial distribution. You want the probability that it's less than 25. Out of 150 sorry, that's less than 25 out of 150 of them. Okay, so this is where I need to remember what like a binomial the binomial distribution equation is. This is fun. Yeah, this is it. Okay, that's what I thought it was. It's n choose k, probability of success times k times 1 minus p, n minus k. Okay, this is what we need to know. Have you seen this before, Noise? I'm sure you have. Wait, where's my... There we go. That's not too bad. Okay. So that's x. Oh, but I want the CDF. Oh, man. Yeah, wait. What's the binomial CDF? Well, you know, I think I can just do it in here. Okay, here we go. So here, we're gonna I just do the approximation stuff. Yeah, right. Okay, cool. Let's just solve this. Let's store this as x. Or using my brain. Yeah, okay. So this is a binomial CDF of 150 trials. Probability is that. Very big value. And then x value is 25. So let's see. So the probability is 0. Is that right? Is that right? No, it's the probability is 0. There's a 0% chance that at least 25. Sorry, what? Or is a 100% chance? Yeah. Yeah, there's a 100% chance, basically. Because this is ridiculous, dude. 80 passengers when you're combined as 44. You're like always gonna check in at less than 80 passengers. Is that right, Noise? Am I doing something wrong? I don't think I'm doing something wrong. Let me know. Curious.
Hey, that's all.
What's up, Ethan?
I want to ask this: how many pages would you usually find in an article?
Usually like 4 or 5.
Like that, I thought articles were like more than 10 pages.
Well, it depends what type of article it is.
Oh, all right, I thought
Yeah, you're good.
I thought I had to make like more than 10. But
No, like
I
4 or
guess
5.
we'll
4 to 5 is okay. All right, wait. Is this the grading rubric for it? One sec.
I'll try to at least see if I can get more. So, yeah.
Okay. Okay, here we go. Yes. Okay, cool. Probably less than 80. Okay, I don't agree with this. The probability that less than 80 passengers checked in is 0.183. Where's that coming from? Yeah, okay, see, yeah. So this was the normal distribution I was talking about. And then they did a t-test here. Or no, sorry. No, this is a Poisson. Yeah. Well, I don't agree with this. I don't agree that the probability that less than 80 passengers is checked in is 0.183. Where are they getting that from? This is okay after this point. Whatever. Okay. Yeah, it's pretty useless, dude. What? It randomly selects 150. They check in fewer than 80 passengers? Oh, I am so dumb, dog. Yeah, my bad, dude. This is where they screwed me here, dude. Look at this. Okay. This is 60 minutes. This is 30 minutes. It's twice. It's twice the rate. Right? So this is really Poisson 88. Yeah. He says, let's play Fortnite. Yeah, give me a second. Let me do this question. Okay. This is Poisson 88. That's what it is. Yeah. They try. Tricky. You British people are tricky, dude. What? Chill. Yeah. So I need this. Cool. 88. Okay, which is still not right. Oh, wait, no, wait, what? Oh, wait, sorry, I have to double each of them. You know, that should make sense. 56, right? And then this is 32. 88, yes. Poisson CDF. I probably have to put 87 in here. Yeah. No. Wait. No, sorry. This has to be 79. And this has to be 88. There we go. That's the 0.183. That's where it comes from. You get that noise? 60 minutes instead of 30 minutes. So you got to double the rate. Oh, okay, cool. Yes, and then this is just a binomial distribution of 150. Right. Yeah. So the mean expected value out of them is wait. T equals Poisson 27.4. This is weird. I think you can do it this way. I think you can do binomial CDF. It's 150. And then this is 0.183. That gets 34%, and then you got to do 1 minus that. 65. It's different than what they get. What was it? At least 25. So at least 25. Oh, it was 1 minus 24. Sorry. Yeah, it's all these off by ones, dude. Screw this. We're still kind of off. Well, okay. Maybe because this is not exactly correct here. Let me store this as X. And then let's do binomial CDF of X. We're going to do the full thing. There we go. Right? 1 minus answer. Yeah, we get closer. 73% instead of 71%. I feel like you can do a binomial for this. Maybe because maybe n isn't sufficiently big. Like maybe 150 isn't big enough. But they do. I don't think we're gonna reach my question. Yeah, we can reach your question. Yeah. Allow 28 for both. Okay, all good. It's a good question, Noise. Let's I like these. Like, these are good challenge questions. Let's get to more to this one next time. Yeah, I don't get the n is large stuff. Yeah, it's just like, this is the problem with statistics. It's like, when is n large? And sometimes they say it's 25. Sometimes they say it's 100. Sometimes it's got to be 1,000. There are some like requirements based on I think what the probability is. You need like the expectation value or the number of successes to be like greater than 10, but like it has to be less than 10% of the population. There's all sorts of fun stuff. Yeah. Okay, cool. All right, that's a good question, Noise, though. I appreciate it. It's a good question. We'll get to the other parts of it another time. Yeah, let me see if I run through Teacups. Teacup, what's up? You here? Gotta find it from yesterday. Is audio working this time? Teacup, is your audio working, please? Please tell me it's working. Teacup. Sorry, you're a bit of a burden? No, dude. No, fuck that, dude. I appreciate your stuff, dude. I really do. It's it's super cool. I had to reteach myself a little bit of binomials and Poisson distributions and all that fun stuff. But yeah, it's cool. Teacup, where you at? Mr. Bean's coming out. We're doing your question. Hop in the VC, dog. There he is. There you go. Nice. Okay, cool. All right, here. We'll do one of these. Let's do just one of these real quick. All right. All right. Continuous. Gotta change what?
I think we did A yesterday.
We did do A. Yes, we did do A. You got work tomorrow? Where are you working, Noise? You working at a pub? Yeah, so let's try. What, you want to try B?
So logically, if we're going in the correct order, we would obviously go to D.
Sure.
It's the only one that isn't a faction. Deal with it.
Okay. We're saying, is it continuous on -1 to 1? Interesting. Okay. Well, this one's pretty easy. I'm pretty sure log breaks whenever you try to do the I don't think you can do the log of 0. I think 0 like breaks it. That's like bad. So I believe
is X representing 0?
Well, no, so X can be anything from -1 to 1 is what they say. They say X is anything from -1 to 1.
So it could be 0.
Yeah, right. X. We say X is included in.
I figured out. It is not, in fact.
Yeah, well, it's not continuous at 0 because I think the log of 0 is undefined. I work in a shop that sells everything. Garden center. Oh, that's cool.
Now, but hold on a second. But then we have the exponent of X.
Right, but e to the 0 is just equal to 1, which is okay. You're right. If this was, for instance, log of X times X, this would become kind of a weird thing because this approaches negative infinity as we get close to 0, but then this approaches 0. So then this becomes the age-old question, does negative infinity kill off the 0, right?
No.
Yeah. And it does sometimes, it doesn't the other.
0 obviously doesn't exist.
Yeah, well, this is where you have to do a little bit more work on it. We have to do.
No, 0 doesn't exist. That's my young Sheldon, obviously.
Yeah. Let's try this one. I want to try this one, actually. I do. Let me try this one. I think this one is just like, I mean, here, I can, what was it? Log absolute value of X, e to the X, right? Yeah. So I can just ask Wolfram. What's up, dude?
My server has reached 1,100 members.
What server?
Yeah, I own a server.
I didn't know you own a server.
I own a Roblox server.
That's cool. Like a Roblox Discord server?
So I got promoted to the owner of.
What game is it?
Roblox. It's like an SCP that I don't know. I don't pay attention.
SCP.
I don't know how I got promoted. I didn't.
That's cool. You want to show it to us in Roblox? You want to show us today in Roblox games? You want to show us your server? That'd be cool.
Nah, I'll just show you a screenshot that encapsulates it perfectly.
Okay. Alright, send it to me. Yeah, so Wolfram says it's not continuous at 0. Yeah, that's what I thought. Cool. Awesome. I was right about that. That's great.
Yeah.
Okay.
Look in office hours.
Okay, send it. What do you have? Oh, this looks cool. Oh, it's like the only thing I know for real, Sam Infection. This is cool. It's like a samurai sword game or something.
No, it's nowhere near that. That was just me messing around. Anybody had at one point.
Oh wow. This is probably a good one. What about this one, guys? I like this one. Okay.
Oh, I don't
Sine
like it.
sine of tangent of x over sine of x. That's a good one.
Dude,
Okay.
the signs cancel out.
No,
Wait,
I don't. I don't. Don't do that. No, sine doesn't just cancel like that. That doesn't exist. Okay.
No,
All
I've
right.
actually decided to change how math works.
I know.
Um,
They're functions.
actually-
They're like
No, I
operators. They
decided-
operate on things.
Anything I don't agree with is just equal to 0.
Oh, okay. 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 Wait, my sound been weird this whole time too? One sec. Let me make sure this didn't fuck up. Sec. I'd be mad if it has been doing that the entire time. No, my levels are fine. Okay. I don't know. It's just being weird. Okay. All right. So things are discontinuous when we divide by 0, right? Which means when this bottom is equal to 0. All right. So when is sine of x equal to 0? That's a question. You should know this. When is sine of x equal to 0? Yeah.
Hello?
Yeah. When is the sine of x equal to 0? Teacup.
When x is 0.
Good.
I don't know.
No, it is. Yeah, no, literally it is. Yeah. Yeah, good. Okay, cool. So we say x is equal to 0 is where this might be discontinuous, but we got to look and see what happens. So the cool thing is that, yes, this would be equal to 0. However, the tangent of 0 is also 0, and then the sine of 0 is 0. So now we have a problem, because we have 0 over 0, which, oopsies, don't know what that is, right?
Mhm.
Okay. I think this is where we use L'Hopital's rule, Noise. This is where we use L'Hopital's. I think we use L'Hopital's rule here, right? So if this is equal to 0 over 0, then I can take the derivative of the top and take the derivative of the bottom. So this becomes, yeah, time for L'Hopital. We do love L'Hopital, dude. So this cosine of tangent of x times the derivative. So this is a chain rule. The derivative of tangent of x is secant squared of x all over the cosine of x. Okay, now okay, when this is 0, this is cool. When this equals 0, right? This becomes 1. Love that. Tangent of x still becomes 0. Cosine of 0 becomes 1. And then secant squared, that's 1 over the cosine squared. Cosine squared of 0 is 1. 1 over 1, 1 over 1. Oh, everything's 1 over 1. It's all 1.
Everything's wrong.
Love
I
it.
have no idea what happened.
It's okay. Yeah, I'll explain it to you next time. But yeah, that's a good question, Tico. Yeah, remind me if you got questions. Yeah, I thought we did yours last time, but yeah, remind me earlier on, or repost it. Just repost it in the chat so that I remember to get to it sooner. Because I don't want you to have to wait an hour and a half for me to answer your question. So you know, in AP Calc you do this, don't you? Yeah, we do L'Hopital's rule in AP Calc. You're right, we do.
Oh,
We
cool.
do.
I
We
have,
do.
I'm doing
What's up?
AP. I think it's AP trigonometry next year.
There's not an AP trig. I think you're probably
that's-
doing pre-AP. Pre-AP trig. That's probably what you're doing.
No, it's pre-AP trig.
Cool,
Hey,
pre-AP. What's up, Ethan?
I have AP human geography.
Should when I write an article, should it be on my own opinion?
Yes. Yes. Well, you should inject
Oh.
some of your own opinion in it, but you should also like write facts. We like facts.
I hate that.
Yeah. Okay.
Like
okay.
facts. We do. Yeah, you're good, dude. Okay. That's awesome, Teacup. Yeah, trig. That what we just did there. That's trig, dude. That's trig.
Well, I have a very important question.
What's up?
Where was Golden Hour yesterday?
Oh yeah. I told people on the stream yesterday that I had to go help my friend set up his podcast. so I wouldn't be able to stream
But
yesterday.
here's the thing. You said on the stream yesterday, but there was no stream.
Sorry, I said on the stream on Wednesday. On Wednesday, I said there would be no golden hour. Yeah. I always make an event for it on Discord if there is a golden hour, and there usually will be. What are we playing? Okay, yeah. So yeah. Okay, all right. Thanks everyone for coming to Office Hours. Had a lot of fun. Enjoy the questions. I like the Poisson stuff, Noise. Yeah, ask me more statistics, dude. I need to learn it myself, and hopefully explain it to people.
Is Ethan really about to change the game when he's writing an article?
Yeah. Right. So yeah. So what we do after so our next stream will be on Monday. That's gonna be at 3 p.m. Pacific, 5 p.m. Central, 6 p.m. Eastern. What we do after we learn and all this fun stuff is we go play video games, and that's gonna happen on the actual gaming channel, which I'm rating right now. So if you're in the Twitch, it's gonna pull you over there. Today's game is gonna be Roblox. I have a feeling Ethan's gonna spend his channel points and switch it to Fortnite. Totally
I have a feeling
cool.
I'm gonna change it back to
Let's just.
Roblox.
You can change it back to Roblox as well, but then we gotta play one game of Fortnite.
I'm about to have a war with Ethan.
Yes. So let's play at least one game of Roblox if someone's gonna change the game, and then we can do things. So, yeah. Again, if you found us on Twitch, you're wondering like what we do. There's our well, no, there it is. That okay. That is our because everything's reversed. That's our Discord. You can go join our Discord there. So yeah, awesome. All right. Otherwise, I will see you guys on Monday. Come hang out with Roblox. Peace out.
Is that the goal?
Yeah, meet me in recess. Ask me in recess. 1 sec. Let's go.
Alright.
All right, there we go. We're in recess. Stop streaming here.